Alright, so for this bell work, the first thing that we want to do is label our sides with S's and our angles with A's. So in this case, we both have one tick mark on these two, so that's one pair of S's. Okay, there's another pair of S's here. And then we have these angles. So can we say that these are congruent or not? They're congruent by what? SAS. Good. So congruent by SAS, because if we spelled that out right as it looks, SAS. Okay, on this one, we would do the same thing. So we have one pair here, another pair here, and another pair here. Okay, if I spell this out, what do we get? Bad word, right? So the only exception is when it's a right angle. So we have our hypotenuse and we have our leg. So this one still is congruent because it's a right angle. Okay, that's the only exception to the ASS rule. So same thing on this next one, label our sides and angles. On this one, we also get ASS. Is this a right angle? No. So this one is not enough information. If it was a right angle, then possibly, but. Okay, and then this last one, what do we get? We got two angles and the excluded side. So AAS would be this one. Because it's not the side in between the two A's, so it goes on the outside of the A's. Okay, any questions on any of those? Okay, so excuse me. So we still have to figure these out on today's lesson, okay? But that's the only lesson of this unit, this little mini unit that we have to do it on, okay? So today we're talking about corresponding parts of congruent figures are congruent, aka CPCFC, okay? So this means that if two shapes are congruent, then their corresponding sides and angles will also be congruent. That's all this means. So we're going to do proofs again. Okay, this is the only one we'll do proofs on consistently. The other ones will have little tiny ones, but not too bad. So we are given these two things. So I'm going to write both of these on this top line. So AB is parallel to CD, and BC is parallel to DA. Okay, and to show that those are parallel, we put little arrows or triangles, however you want to do it, to indicate these two sets of sides are parallel, not congruent. Okay, tick marks are the congruents. So since we know that those are parallel, this is our transversal, right? So we can say the angle CBD is congruent to BDA. So angle CBD is congruent to angle BDA. Okay, that is because they are alternate interior angles. Okay, there's another pair of angles that I can say are congruent. So we got this angle right here and this angle right here. So angle ABD is congruent to angle CDB. Okay, and those are also the same thing. So I'm just going to put that. Remember, those quotation marks mean the same as above. So we have two sets of angles right now. Is there anything else that we can say is congruent? Yep. We can say that side BD is congruent to itself, right? What property is that called again? Yeah, reflexive property. Good. Okay. So now we can say that these two triangles are congruent by ASA because it spells it out right there. Okay, and then this is our only new part. We can now say since our two triangles are congruent, that these two sides are congruent by CPCFC. Corresponding parts of congruent figures are congruent. So since these are congruent, we can say that the corresponding parts are congruent. A, B, and C, D right there. Okay. So hopefully these look a little bit familiar. And then this is our new section today. Okay, any questions on that? All right. So let's go on to the next one. We'll do this one together and then I'll have you do the last one on your own and try it out. All right, so it says given ABC is a triangle, okay, that's triangle ABC, and side AB is congruent to side AC. Okay, so that's what we're given. It tells me that these two angles are congruent because it's a construct of a angle bisector. Remember, bisect means to split into two equal parts. So since that angle is bisected, it's split into two equal parts. Okay, then on this one, we can say that side AD is congruent to side AD because of what property? Reflexive. Reflexive property. Okay, this spells out SAS. So we can say that these two triangles, so triangle BAD, and then we have to mimic that on the other side. So we went from B to A to D. So on this one, we have to go from C to A to D to make it match up. C, A, D. So those two triangles are congruent by SAS. And then our last one is the only new part, CPCFC. So every single time that CPCFC will tell us whatever is congruent after we determine the triangles are congruent. So you got to make sure you determine the triangles are congruent and then you use CPCFC. Okay? Any questions on that? Okay, go ahead and try this next one out. Okay, we didn't give you how many boxes to use, so use as many as you need. I would write statements and then your reasons and start filling it out as best as you can. Remember, your last line will always be whatever you're trying to prove in CPCFC. And the line before that is going to be your triangle congruency. Try it out. I'm going to go over it in a minute or so. So, the first thing is given to us up here. Okay, this is the perpendicular bisector. Perpendicular can be used as this symbol. Okay, that shows a 90-degree angle. Okay, so due to the definition of perpendicular bisector, it means that these two sides, remember, are cut in half. So AP is congruent to BP because of the definition of bisector. And then we can say the same thing about these two angles because they're both right angles, right? So angle APC is congruent to angle BPC. Okay, you could have done those two in either order. Okay, and then this last one, the reflexive property hopefully you got was PC is congruent to PC. So then when you do this, any form, you just have to make sure angle A and angle B match up. So A and B are both first, both second, or both last. And then P would be in the middle, and then C and C. And then lastly, the CPCFC, that's what you're trying to prove. So side AC is congruent to BC. Awesome. By recording.